In this particular video, we're going to talk about more algebra applications of Maxima. And in this case, we're going to concentrate on quadratic equations, the second order equations, which are kind of like the culmination of very elementary algebra. And so we can start by looking at this document in which we have our generic quadratic equation, ax squared plus bx plus z. I repeated it here into variable eq. I subtract c and divide by a. Okay. Expand the left hand side and the right hand side. Add b squared over 4a squared, which basically completes a polynomial, a trinomial here that corresponds to a quadratic or a square expansion. Then we do factoring of both sides. I'm factoring of the left hand side actually, and red simplify of the right hand side. We have the denominator for a squared on both sides, divide or multiply by 4a squared. To simplify things, we end up with this equation. Take the square root. And then we have in the left hand side an absolute value. The absolute value means that the right hand side can be positive or negative. And actually we do have two possible solutions. If we take the positive case and then subtract b and divide by 2a, we get this result is minus b plus the square root of b squared minus 4c over 2a. With the negative sign, we get minus b minus the square root of b squared root. So these two results can be summarized into the famous quadratic equation formula. Given the quadratic equation ax squared plus bx plus c equals 0, the solutions are minus b plus minus square root of b squared minus 4ac over 2a. Let's try this equation, for example. Which we'll rewrite so that all the terms will be on the left hand side. We can identify a equal 1, b equal 12, and c equal 16. We're going to call the quantity under the radical b squared minus 4ac d. It's called the determinant d. And then we can write the equations x1 and x2 this matter. So there's a, b, c, there's d, and then the x1 and x2, two real roots. Here's another example. We identify a, b, c, calculate d, calculate x1, x2. The application of the quadratic equation solution is straightforward. In this case, the determinant is equal to 0, so we have two real roots. Another example here, identify a, b, and c, calculate d, calculate the two roots. Quadratic equation with denominator, this needs to be expanded and simplified. Multiplying by the denominator, expanding, subtracting the left hand side minus the right hand side, simplifying, identify a, b, and c, apply the quadratic equation. Here's another example. Expand the cross products, subtract the left hand side minus the right hand side, identify a, b, and c, calculate the determinant, calculate x1 and x2. Through factorization, if we can factor the equation, then we basically have these two terms have to be equal to 0 separately. So we use solve in the linear solution, and we obtain the two results. Let's try this one. We expand first, simplify, multiply by 3, subtract 9, factor the equation. We get x plus 2. Those two terms must be equal to 0, corresponding to the values of x of -2 and minus 4/3. With literal coefficients, let's say, by the way, when we say something like a column, comma a, that means clear the value of a. A becomes just a variable a, b, and c. This is necessary because I've been using a, b, and c before, and I want to use literal equations. So now I have this, and I'm going to change the symbology from lowercase to uppercase. A, b, and c, my new determinant, and my x1 and x2 are given in this way. Simplifying with radcan, I get b plus a and minus b minus a. Here's another example. Well, the roots are b over a and minus 2. With radicals that are reduced to quadratics, subtract x, square, expand, subtract what is needed to make one of the sides equal 0, factor that equation, and then this is simple, straightforward, that since these two terms must be equal to 0, the roots are 12 by minus 2. Another example, the square of the square, square the equation, subtract 2x, square the resulting equation, expand, subtract to make one of the sides equal to 0. Since 4 is a common term, that we factor it out, and then factor the resulting equation, and we find that the roots are 7 and 3. Using Maxima, you can just solve, and it will give you directly your equations. You don't even have to expand them. Maxima will do that for you. And so that's one of the advantages of having Maxima at your command. But equations that involve radicals are not easy to solve directly, so we're going to have to use, for example, find root numerical solution. Graphical solution. Well, we have to create a function that is going to represent that quadratic equation and then draw a picture. The points of intersection with the x-axis will be the roots of the equation. In this case, we have x equal 1, x2 equal 4. This is a simple one. Again, the graphical solutions are not necessarily the best. Clearing all the variables here. What happens if we have complex solutions? If d is negative, then the solution will be complex. For example, in this case, d is equal to minus 27, and then the root will have I in there. How does the equation look like? If we have an equation with two imaginary roots, the curve never crosses the x-axis, so it remains on the upper side, or in the lower side if the coefficients are appropriate, but it won't cut the x-axis, so there is no real solutions. Word problems that result in a quadratic equation. The length of a problem extends by its width by 4 meters. If each side is increased by 4, the area will be double, and the area is x times y. Equation 1, from which we get y equal x minus 4, substitute that into the second equation, expand the equation, left hand side minus right hand side, solve. So it turns out that the length will be 12 and the width 8. 12 times 8 is 96. If we expand that, the area would be double. The difference of two numbers is 7, and its sum multiplied by the sum of those two numbers is equal to 184. So the difference is 7, and the sum multiplied with the smaller is 184. Substitute y equals 7 minus x minus 7, into x plus y times y equal to 184. Expand the equation, subtract 184, factor, and the roots are 15 and x equal minus 9 over 2. And so those are the solutions for this particular situation. So this is the application of Maxima to quadratic equations. You may think, well, it's a joke, but if you have to do algebra and check your problems, it probably is going to be very useful. So with this, we finish our quadratic equations video.